Well, now it's part four of the four parts. We'll look into how the BS model is interpreted. The interpretation of the BS model. We have seen how to calculate, you have seen the example, uh, and how to interpret the D1, D2, and ND1, ND2, and how to plug it into the equation. And you also have seen one numerical good example. Well, interpreting the Black-Scholes formula, right? Now, interpreting the Black-Scholes formula is that it may look so complex at the first sight, but it has surprisingly very simple interpretation. A few things. There are but only 6 variables involved in the equation. We discussed this below, including the interpretation of the term ND1. What do you mean by ND1? And then the quantities of S0 times ND1, the one part of the equation. And the second part of the equation where you minus is the present value of the K times ND2. Naturally, when you describe what is ND1, you have to describe what is ND2. Well, we'll look into it one by one. The complicated looking formula, but we can assign some intuitions in the terms of the formula and see actually what it means. Let us use a call option formula. That is small c equal to S0, the current stock price, times ND1 minus present value of the K, that is the present value of the strike price, the K e power of minus RT times ND2. Only these two involved here. So one part is the current stock price times by the ND1. The other part is present value of the strike times by ND2. So what is ND2 first of all? ND2 is the risk neutral probability that the call will be exercised. Risk neutral probability that the call will be exercised. And what do you mean by ND1? Normally we call it as the delta. When you go into the Greek letters part of it in next 2 weeks, you will learn what you mean by a delta. We have got delta, vega, gamma, and theta. Okay, delta is the change of the call price, the main one, due to a small change in the stock price. When the stock price changed by $1, by how much the option price will change? That's what you mean by delta. Okay, that's why we associated the D1 with S0. So S0 times and D1 is the price of the derivative that pays ST if the ST is above K and otherwise 0. KERT, that is the present value of the K, times ND2 is the price of the derivative that pays K, that pays the strike price if the ST is above K. We are talking about call throughout and 0 otherwise. Okay, let us revise back. Can you remember in week 5 we studied, or week 6 we studied properties of a call? What induces, what affects the call prices? Value increase as stock price increase. When the S0 keep increasing, the price of the option also will increase. Call option price will increase as the stock price increases. Call option value will increase with the interest rate. Higher the interest rate, higher the call option premium price. Value also increase with the time to maturity. Longer the time to maturity, higher the value it is. Okay. Value decreases. This is the only possible one which has got what we call inverse relationship here. Value decreases with the increasing strike price. When the strike price increases, this is a call. When the strike price keep increasing, the chances of you exercising is keep decreasing. That's why the value decreases. Value increases again with the variability of the stock return, the standard deviation itself, the volatility. Value increase with the volatility increase. Now you should know which component of the variable will affect the option price. So we have got about 5 here. Actually, you should have 6. Well, that's the time to maturity is also there. Interest rate is there. Current stock price is there. Strike price variability is there. And out of most is the standard deviation itself, the volatility itself. Well, it's opposite to the puts. Value decreases as the stock price increases. As the stock price increase, your chances of exercising it becomes lower and lower. Value decreases with the interest rate. Higher the interest rate, lower the value of the put price. The value increases with time to maturity, that is same to all, whether it is puts or calls. Value increases with time to maturity. Value increases with increasing strike price, of course. When the strike price increase, we are getting nearer and nearer to the chances of exercising. Value increases with variability of the stock returns. This is same for all, whether call or put. It is same. Hello. I'm coming because I'm re-recording the whole thing. No sound just now. No, no, no. Wait. Okay. No, no, I told them to try to call them, but they didn't take. Okay, okay, wait. I'm recording. Right. Okay, the value increases with the variability of the stock returns. If the stock returns have got higher volatility, so the value will increase. Well, we look into the volatility of the return itself. The volatility or the sigma is the only input that needs estimating, where we know that the only unobservable variable in the entire equation is the sigma. Uh, it is the standard deviation of the return in 1 year, that annualized measure of the standard deviation, when the return is expressed using continuous compounding. Generally, it can be estimated using historical return data. That's what we call it, historical volatility. Or you can use current option price itself as the implied volatility. It is usually given as a percentage per annum. You need to write it as a decimal to input in the BSM model, because in the BSM model, the standard deviation is zero point 0.2, like for 20% per annum, 0.3 for 30%, and so on. Let's say in this case, there is an example with the 0.25. The standard deviation of the return in variable time, where the standard deviation square root of the change in the time. Usually we take it as the terminal time. So here when we are calculating it for 1 year, so it is common that 1 year trading days or stock market trading days are 252 days. So 0.25 is the standard deviation, square root of 1 over 252. Many students have asked me in the past that why is it 252? Internationally, it is standardized that 1 year stock trading days are 252, not 365. So in 1 day, it becomes 0.0157, that means which is 1.57%. Okay. Now, volatility input. The volatility is the only unobservable input in the model and is very important, I told you, without which you can never estimate the Black-Scholes-Merton model's call price or put price. We can use the historical volatility to calculate a series of returns, or the implied volatility to calculate the traded option price. Some traders and institutions have a subjective approach where in estimating the input of the volatility, because it's a key thing. Sometimes use some combination of implied or historical and forward-looking volatility to capture the right one. There are other techniques for estimation using gauge and arcs, and which is we don't have to cover that now. Okay, implied volatility. What do you mean by implied volatility? When you use historical volatilities, calculate from the series of return, or the implied volatility calculate from the trader option price. In practice, traders usually work with implied volatilities. These are the volatility value backed out from the market option price using BSM formula. Implied volatility is volatility that which matches option price observed in the market to Black-Scholes-Merton model price. For example, if a call option price is trading at for a stock price which is trading at S0 currently 30, which has got a strike price of 30, that means the return at the money, which has got a 5% return annually, continuously compounded, and time is half a year. It's selling at $2.89. That is the price of the call option. Then the implied volatility is the solution to the equation. Okay, the implied volatility is why you calculate the BSM model solution. That is S0 times ND1, that is 30 times ND1, minus present value of K, 30 times to the exponential power of minus 0.05 times 0.5 times ND2. This is a one-to-one correspondence between price and implied volatilities. The price of the call itself becomes the volatility. But normally in my exam questions, I don't use implied volatility. You have to use whatever given value for the historical volatility. Traders and brokers are often quoted. Traders and brokers often quote implied volatilities rather than dollar prices. Okay, we don't have to go too deep about the implied volatility. Let us go into the summary. Assumption of BSM model we have seen. How to apply the BSM model also you have seen. What is the effect of changing inputs, the option price, like in the form of stock price, the strike, the returns, interest rate returns, the time to expire, and very importantly, the volatility. To know how to use normal distribution. Hello? Wait, I'm still recording. Wait, I'll call you back. Huh? Uh-huh. Wait, 1 minute. Wait, wait, wait.